that the Rodale Institute expanded here to California just before the pandemic. So the Rodale Institute is probably most or all of you are familiar with it, but it's based out of the East Coast of the United States in Pennsylvania, where they've been doing research for in excess of 75 years at this point, and it's the site of some of the longest side-by-side organic versus conventional field trials. We do a variety of things out in Pennsylvania, but that's what we're most famous for, is that field trial of a longstanding agronomic assessment of the benefits of organic versus conventional. About 5 years ago, Rodale had the leadership had the vision to move into the regenerative space. Regenerative had been gaining ground as an idea to expand beyond organic certifications, beyond organic practices, and the critique of organic was well founded in that organic never had really been focused on systems or on particularly on soil health. It was mostly organic was a response to the problems of biocides, of pesticides and herbicides, chemicals that are poisonous to humans, basically, and that's a legitimate problem. So organic was received well by and has been received well by consumers, but in recent years, as science has expanded our understanding of what's happening in the soil health component started to gain ground, and there's critiques of organic being problematic for soil health. So in response to that, Rodale began to do research into what are regenerative practices. And one of those practices I'd like to talk about today is the introduction of animals into farming systems. So this is generally called animal integration. So my own personal experience with that is that I have an almond orchard here, and we have a few different animals that we've been integrating into our almond orchard system. The easiest of those to integrate has been sheep, and I'll talk about kind of the details of sheep as a tool in an agricultural system in vineyards, though. We also in our almond orchard have been integrating chickens. Those have been less easy, but that's the example I'm going to talk about in our orchard. So in an orchard system, an almond orchard system, almonds are a Mediterranean crop. They're based on a system with low rainfall in the winter, in the summer, and high rainfall in the winter, and that means that the animals are best, grazing animals are best integrated into that system in the winter. So we can send chickens through there, or sheep, or any other animal, practically speaking, in the winter when there's grass growing on the ground from the rainfall. This, in theory, works well for our harvest system, because almonds are harvested in the late summer. In fact, we just harvested day before yesterday, which is part of what I'm busy with my truck and trailer, moving almonds from one spot to another. So and that's good for the animal integration part, because that means the animals are out of the orchard by the time that harvest comes, and we need to have machinery out here, and we need to have people walking through the orchard. It's also good because the trees are growing most of their growth in the spring, which means they need to have fertilizers applied in the winter. This is different. This is a critical point, because in a conventional system, the fertilizers are applied when the trees need them, because a liquid synthetic fertilizer is available immediately to a tree as soon as it's sprayed onto the ground or injected into drip irrigation. It's immediately available to the tree, kind of like drinking a soda. You drink it and immediately you feel that energy from the soda. In fact, it's a direct analog, as opposed to if you're applying an organic fertilizer that's in the form of pelletized manure, or bat guano, or whatever the case may be, that has a much slower cycle of availability for the tree. And that's exactly what we're doing with animals, is we're applying a manure fertilizer. So when the chickens come through our orchard, they're applying fertilizer as a part of their own biological processes, and they're pooping out fertilizer for us, and that's very slow to be uptake by the trees. So if we want to have a good crop, we need to have the fertilizer applied in the winter, so that by the spring, when the tree is growing, it's the most productive, that fertilizer has broken down, it's been absorbed into the soil architecture, and it's now available for the tree. So fertility is one aspect of animal integration that works well in our context of when the animals can get out there. There's also some side benefits. The chickens are able to do some pest management for us. As you can imagine, they're going to eat the bugs on the orchard floor, especially at the early stages when they're still worms, the early life cycle stages of the pests. And that helps us because there are a number of problematic pests in almonds, particularly the navel orangeworm, which overwinters in the unharvested almonds. And those unharvested almonds, maybe the machines didn't get them, or they stuck in the trees, they didn't fall down. But during the winter is when most of those will fall down from storms coming through because of the Mediterranean climate. And now that those almonds are on the ground, any animal, chicken, sheep, cow, whatever, would be happy to eat that almond that has the worms inside of it. And now that the idea is that our pest pressures will be lower. And that's a normal. Normally, we'd be addressing those mechanically. I would drive a tractor through the orchard to grind up those almonds that are on the orchard floor, and now we can have animals taking care of that problem. So there's some of the side benefits have direct monetary value for farms, at least for our farm. The third benefit, and this is applicable across case studies, across various crop systems, is the biodiversity component. So in our case, the chickens that we would have out in the orchard add biodiversity. It's another species in the orchard, and it's just one other species, but it creates a ripple effect very quickly, because as you can imagine, chickens, they would prefer a diverse diet, and in order to manage those chickens, we want to for their own health, we want to have a variety of foods for them to eat. So what we do is we plant a cover crop on the orchard floor that's grazable for the chickens, and this would be the same in other case studies, and I'll mention, like I said, the sheep and vineyards, and we might get into cattle and wheat as well. But in the case of the chickens, they're gonna want to graze on some plants that have more protein, some plants that have more fiber. So the same as humans, the same as most other grazing animals, the diversity of their food is important as well. So that same menu that they want to eat is actually beneficial for the orchard too, because if we're planting some high protein plants like peas and beans, those fall into the legume family. Those also are nitrogen fixers, and they'll also help our trees with the a part of their fertility budget for the orchard. Same thing with the grasses and some of the other diversity that in terms of fiber for chickens. Those will have a root system that's very fibrous and is going to help with our water filtration, water infiltration into the trees, so that the diversity within the chicken's diet also is a symbiotic or beneficial diversity for the orchard itself. The last benefit of animals and chickens in this case is the overall systems, and this is something that I would like to develop further, and I'm sure that people have thought about this a lot, but the kind of the big problem with agriculture as we see it is that it's a system problem, that humans have built up a rigid and robust farming system that is reliant certainly on chemicals, but it's also reliant on a bunch of subcomponents that are hard to create a holistic system change to, kind of not to throw this out lightly, but the problem of transitioning to organics in Sri Lanka was largely a problem of systems change, and the relationship of chickens to a agricultural global economic system, the food system, the farming system. The relationship of chickens to that is that it pushes us to change in very subtle ways, but ways that are systemic at heart. So, for example, with the fertility component, we're getting a little bit more fertility from the chickens being in the orchard, which means we can order less off-farm fertility inputs from any other sources, whether they be conventional or organic or otherwise, and that's less of a footprint that we have in the standard supply chain for our farm. You know, it's just a small push away from a huge system of supply inputs and petroleum reliance and corporate interests that's useful for the viability of the farm, but it's also like I said, it's a small systems shift, and there's other aspects to that too, that in terms of where people are working at on our specific farm. So I can employ more people on my farm as opposed to employing them in aggregation systems just by the chickens being there. And it's like I said, I would love to flesh this idea out of how animals can help us push towards more integrated community agriculture versus corporatized farming systems. Food safety is the first question that comes up, even though I didn't mention it at all in my kind of initial kind of foray into this example of chickens. Food safety is the big question that people have, and this maybe I'll address it kind of in the reverse order that I talked about the other ones. So I'll start with the system level. So at a system level, food safety is there's protocol around food safety. We all know that, and as science has informed that protocol, you know, why do we have food safety? What are the basis of our parameters for food safety? So there's a system there that we maybe called our food safety system, our healthcare system, even more generally speaking. And obviously, there's wildly disparate opinions on how animals benefit or challenge our health systems. But not getting into that too much. We know the regulations around food safety right now are that you need to have no raw manure applied or no animal contact, maybe an easier way to think about it, in some amount of time before the harvest occurs. And that's usually 3 to 4 months, depending on all sorts of various factors. But so if there's some amount of time before we want to eat something, if an animal has touched it, or we know that it's going to have to get washed alternatively, then it's just a question of logistics of getting animals in there. And the interesting aspect of this is that out here in California, as I said, we're in a Mediterranean climate, and our food systems our farming system is based on that climate, those climate parameters. So if we get rain in the winter, we're harvesting in the summer, then and we can only have animals in there in the winter, then that already allows us to be outside of those food safety windows. And it, maybe that's just our lucky situation out here, and it is to a certain extent, but it also is a reflection of the appropriateness of what we're growing and what our animals are. So in other words, we need to be making choices about what we grow based on our climate. That makes sense, obviously, but it's not true for corporate agriculture. Corporate agriculture is growing commodities independent of what our climate is, and obviously that's led to all sorts of problems in the world. But a smart farmer is basing their long-term cropping systems based on the climate. And if you integrate animals into that, oftentimes the case is that already falls into a system, or creates a model that is within the guidance of food safety. Sorry, that was a really long answer just to say that for us, when we put animals in our orchards, in our vineyards, we only have them in there at times when it wouldn't affect the food safety aspects. This is based on very preliminary results because regenerative practices are one, poorly defined, and two, usually in the context of some other overarching goals. And we're very early in the per the core definitions, we're very early in the development of regenerative practices. But generally speaking, we use 3 years as a kind of a rough estimate for transitioning to organic, which matches well for the requirements of organic transition. The certification requirements require a 3-year gap since the last application of synthetic or non-allowed substances. So that kind of works out well anyway, but it does seem to take about 3 years for the land to respond, or probably more so for the human managers and operators to get a good feel for the system. They have 1 year of just implementing when they don't know what to expect. They don't know how to even do it. They have another year of responding to that, and then in that 3rd year, they're really getting a feel for the systems, and they're starting to tweak the minor aspects of how they're growing their crops. But it does seem like the soil, the trees, plants take about 3 years to develop a kind of their own response to that in an organic system. our expectations is that that would be very similar for regenerative practices. Like I said, regenerative practices are early in the process, though. So if your regenerative practice is to cover crop, whereas before you'd maybe you're already certified organic, you want to add on a cover crop into that system, as before you just applied compost. That's a fairly minor change, so maybe it would only take a year for to see some response for that. There's some really exciting experiments, trials going on right now to tease out those exact questions. So if you want some specific researchers to talk to about specific crops and how they're responding to regenerative practices, just let me know and we can make those connections. And then the second one about visible, that this is an ongoing debate about how to track regenerative soil carbon is kind of the biggest and easiest metric for people to look for, but for a lot of reasons that's problematic. My own personal recommendations is for farmers, it's just a visual test to see what's happening on the ground instead of a soil test. What are your plants doing? So letting your plants be the litmus for what's happening below ground, and they are excellent at doing that, expressing their happiness with what's happening below ground, especially a cover crop blend, a diversified cover crop blend with maybe 10 species in there. Now you have 10 separate indicators of what's happening below ground, and some of them will be measuring your water cycling. Some of those plants are going to respond to pest pressure. Some of them are going to respond to fertility cycling aspects, some to soil, clay layers, and so physical structures within the soil itself. So and it's also fairly intuitive for people to look out into a crop and see, oh, these things are yellow, these our peas are yellow. What does that indicate about the health of the soil? So that's my own kind of just kind of easy visual, literally visible measurement that I recommend to farmers is plant a cover crop. I'm sorry, and make a note of what species are responding well or poorly over time, over the course of the season. I think that the root of the problem is that we've built kind of comfortable financial models around the idea of efficiencies of scale, and when we have some break in that in those systems, in for example, when we weren't able to get cheap fertilizer during the pandemic, and the price of fertility skyrockets across the world, and particularly here in California, we saw really high cost of synthetic fertilizer, and all of the conventional people moved immediately over to compost. I mean, everyone was applying compost, and because it was cheaper, it was just a simple economic question, and that changed the dynamics of farming here in California very quickly. We have a lot of dairies here in California. California is a major milk producing region in the United States, and those dairies produce a tremendous amount of manure, and that can easily be composted on site. And so then the question, the bottleneck was, do we have the tractors, the equipment to produce compost on site? Previously, that was just a waste product that the manure from the dairies was sold for very cheap or even given away because it was just a waste product. Now it has high value because of some other, global issues in the Suez Canal or wherever. So that could have been, for us here in California, that could have never occurred because, if we had had smart policies about our local infrastructure, we would have recognized that this is a missed opportunity to have this local compost available. We could have invested in early on or in the, sometime in the past, we could have invested in getting dairy farmers access to compost making equipment. We could have incentivized that through our policy. We could have given tax breaks for purchases of those equipment, and that's happening now. Those are exactly the kind of, in hindsight, we should have done that before we had this global emergency. So I think that's a good example of how we can be smart with our local resources in the future to engender regenerative practices on farms. Carbon smart farming is a big buzzword here in California these days. We have a lot of public government money being spent on carbon smart farming, and what does that mean? That's one of the main thoughts on that is reduced tillage. Well, let's drill down into that, and what's the bottleneck for that is that most farmers don't have no-till drills. There's a whole bunch of other things, but that's this technical, the knowledge part is also a gap. But if you actually don't have the equipment to implement the practice, then how do you solve for that problem? You can incentivize it with tax breaks, but you can also incentivize it where at a local level by helping farmers to collectively work together and form co-ops to own equipment that's shared among farmers. And that gets to some of the roots of the problem of how do communities take ownership of what's being farmed, when is it being farmed, who has access to that, as opposed to a corporate entity that's based on global interests and is not going to be making decisions based on local climate, local access to resources like fertility, like water, and like local market needs. So sorry, I kind of spun that back into the paradigm question, kind of back into local and community access. But I think that does speak to the profit margins question too, which kind of precipitated the paradigm model. Is that at the end of the day, profitability is what drives farmers to make their decisions, and if that profitability is contextualized to where they're at and to their to their local markets, then they're much more resilient. Their profits are going to be resilient, independent of global fluctuations in commodity pricing. In terms of monocropping, that it really goes back to why I introduced the idea of animals out there. In a regenerative system, we know that monocrops is a major problem, especially year after year monocropping. If you have a crop rotation, that solves a lot of the problems. That takes care of your diversity problem for a lot of the problems, mostly pest management and disease management. But the more diversity you can get in there, the better it's going to be for your system and for the health of the economic health of it. The once again, the disease and pest pressures, the water cycling is going to be better. Your fertility management can be better. Just the more diversity, the better across aspects. So if you can figure out how to integrate almost any regenerative practice into your farm, especially on a monocrop farm, that's going to push your comfort and you push your the benefits of more of those systems. So if you can imagine how to graze animals, and this goes back to someone's earlier question about vegetables. Let's say you have a vegetable operation and you have maybe 4 different vegetables rotations across over the course of your growing season. So this would be common here in California. You'd be growing cabbage and then lettuce and then maybe leafy greens, spinach. Say you had those 3 crops in the course of the year. If after that you say, I want to graze sheep in the winter, and we move the sheep in after we've had our 3 crops, you're going to have to make a few adjustments to your farming systems. You have to make a huge adjustment to your mentality, but those adjustments are going to allow you to maybe do something, have a year of just growing a cover crop out there. Those adjustments allow the farm managers to imagine, how they can be integrating other practices across the board.